Yes, ma'am, you're audible.
Okay, great. So yesterday we discussed this question. Anyone tried doing it? Guys,
Mm,
be fast.
I was just doing the tree. I
Okay.
didn't get a chance. Yeah. Ma'am, which Udemy author should I?
Actually, sorry, I just checked your message, but I'll just go through that course. I'll see what is the name of the author and will ping you. By tomorrow's morning, I'll tell you. Okay.
Ma'am, is there any something which is very basic for recursion? Like I want to practice a lot of recursion. It has to,
Recursion, I told you guys 3 steps, right?
yeah,
One is
base.
assumption. Just give me a minute. Sorry, guys, it was little important. That's why I just took the call. Yeah. Anyone tried to do this? Find the path from A to root, A, B to root, and remove the redundant nodes. You were saying that you were going through the trees.
Yes, so I kept on doing root dot data, sorry, node dot root to find out that length,
Mm-hmm.
and so adding that, and that's where I stopped finding the length with respect to the root or the depth of the element from the root.
Can you repeat what you're trying to say?
So I tried to find the position of any given element with respect to the root,
Mm-hmm.
um, and then adding them, adding the path, adding the number of counts like in a while loop going up till the element I, but I could not go till the end by removing the redundant node.
Okay. Kishan, what did you try and were you able to do it? Okay, you have sent me the code and you've sent me actually two codes. What are these for? Okay. So we'll just quickly write the code for this. Did you ran this code? Was it working fine?
No,
Yes.
no.
Okay. And Kishan, did you run your code? Okay. And did you did on any platform or like you manually did it? IDE. Okay. Guys, from now on, please start. Okay. From now on, whatever question I'm discussing, I'll put the link of it in the group so that you guys can test it on some tested IDs like InterviewBit, HackerRank, HackerEarth, or you can say Lead Code. All of these are like you will test it, you will get to know okay if your question is covering all the test cases required or not. Clear? So that is necessary because as of now, like whatever you will write, you will feel like okay, it's working. But when you go through several test cases and then check your code, then you will actually know if it is working fine or not. Okay. I'll quickly write the code. Okay, that's great. Ashok IT Hacker Rank, are you talking about overall, Kishan, or you are talking only about trees? Overall, also not left bitwise graphs remaining. Okay, fine. Okay, that's great. If you have done that, I'll share more questions. So first is we need to write the code for the path. So leave that. I'll just Kishan, can you send the code in the what should I say? Telegram? Because I am not able to copy it here. Yes, please do. Okay, connected with office laptop. What should I do? Can you attach the okay? Can you attach the file to the Zoom? Okay, now I guess it came. Okay, so guys, are you able to see it? Okay, perfect. I'm not sure why this whiteboard is giving me so much problem. Okay, so basically he has written this path function list. He has taken two lists, written the find path function, which is a different function. Then L1 dot retain all L2, it's basically some inbuilt function which is removing the common nodes, and only those nodes are getting remained which are not common. Then finding the length. Sorry, Kishan, are you merging L1 and L2? Like, except the common nodes, the remaining nodes, are you merging it in the L1? Okay. So retain all is basically he's adding all the unique data of the L2 to the L1, and then he's finding the size of L1, and that's it. The work is done. Clear? So sometimes the inbuilt functionalities help us a lot, and you can clearly see an example over here. Clear, guys?
So I think it is not going to remove the common one. So when I do retain all, it
Mm-hmm.
will retain the common elements, but we have to get rid of common
No,
elements.
it is gonna retain only the unique elements, and the common elements are gonna be erased. That's the target of this particular function. Clear?
But even if we get rid of the common elements, the like one of them, like the root and the child, which are common, they need to be removed completely because they are kind of extra.
You
No,
are
I'm
getting my
just
point, right? It is removing the common nodes from L1 and L2, right? So that
completely.
means, yeah, completely. And
Okay.
then it is merging L1 and L2. So what's the problem I'm not getting here?
Okay.
Able to follow? Even you can do it like, what can I say? On your own. Like it's not necessary you can use some inbuilt functionality and do it. You can do it on your own as well. It's not an issue at all.
Okay.
Clear?
Yeah, but it is good that yeah,
That an inbuilt function is doing the work which you need to do.
yeah. Okay, thank you.
Exactly. So in this, to find the path, we'll check if our root is equals to null. Simply return from there because this whiteboard is running too slow today. I'm writing this code because it's little important. Otherwise, I would not have returned it. So bear with me a little bit and the slow whiteboard. Next is to find the data. You need to check where your A belongs to. Simple. It's a searching process. If A is greater than root.data, you need to go towards the okay. Thanks, Kishan. So to know the functionality of retain all, I have just pinged you guys a link. You can go through this if you're not able to understand what retain all. If A is greater than root.data, then you need to move towards the right hand side of the tree, right? So you will first add this current node to your list, that is list dot add your root. Then you need to move towards the right. So you will write here or call here the find path function. You will call your root dot right. Then A will be constant and your list will be constant. Clear, everyone? And that's it. I guess this is it. Next is else. If A is greater than root dot data, so I'll just copy this. Else if it is the root itself or if it is A itself, then you can return again. No, you need to add here list dot add And that's it.
Ma'am, 1 second. So this else part, I have a doubt. Like else will come only into picture when a is equal to root dot data.
Correct.
So I mean, I'm just considering that either the element is duplicate or the root dot data is itself the a. These are the two possibilities.
See, the thing is, if in the question you have been given A and you are getting A in your like finding in the tree, then you need not consider a duplicate scenario. Okay. Once you have found an A, then you just need to consider that, okay, I found the path. If there will be duplicates and there will be certain other conditions which needs to be added, that will be provided in the question. So right now you can consider it is unique. Clear?
So if in the else block, in that case, it will be just return. Why? Because the given element is that element, then only it will come to else.
The thing is, you need to add to your path A also, right? Like if you're able to find your A, you need to add it. If you don't add it, how will you know, or how will your path know that you have reached A? You need to find the like the distance from root till A, right? You
Yeah,
can't
yeah,
skip A.
correct. Okay, I got it. Yeah.
Okay. So if you guys like now you have these two code part, you can try running it and you will be good with like finding the path from A to B. Now moving on to maxim. So in the maxim yesterday we discussed how can we find. In the maxim I asked you guys that how can we find the maxim in a tree. Then we decided that okay, we have to consider every pair of nodes in a tree, and then we need to like find the sum, and then we need to check if like we just need to store that sum, and we need to check if that is max sum compared to our current sum we already have. Are you guys getting it? Yes. Okay. Any better solution that we can have in here? So now only we discussed that can you do this finding out the pair path like n square part? Are you good with that?
No, madam. No.
Okay, you are stuck there. Okay, other than that though, I have given you the code, so there is no other problem in that. Okay, so we will figure out how to find the n squares in some time. I'll just move on and I'll show you guys next set of approach that we can look this problem with. So you have -3, 5, 12, 6, 18, -2, -1, 9, -19, 19 and minus 4. With from minus 2 we have 4 and 18. Here we have just give me a minute. Okay, so here it will come as 7 and 25. Now consider 12. If we consider it to be the root of the path that passes through it. Okay, like let's suppose this is the root of the path that passes, like let's suppose this is the path we are going through and 12 is the root of it. Okay, then we can find the max in the left subtree and the maximum in the right subtree. That is, if 12 is the root, you can find the maximum in this left subtree and report it to the 12 that okay, this is the maximum sum I have got. And then you can find out the maximum in the right subtree and then report it to the 12 that okay, from the right hand side I have found this much is the maximum sum. Yes or no? After that we can do like add 12, like that is root, right? So we can add root dot data to the maximum sum from the left subtree and then the maximum sum from the right subtree, and overall we will get our maximum sum. Yes or no?
So, ma'am, how we report, like just by returning
Yeah,
every.
correct. Returning, like if 12 is your root currently, then what is the answer returned to it from the left hand side and from the right hand side?
Yeah, ma'am, I'm like, just if I have to do this maxim, I will never go to the left because left is always small. No, no, no. Okay, no, I take my words back.
It's not like you need to see if it is negative and you will proceed or not. It's like it's a mandatory thing. If you are considering some node as your root node, you need to find the maximum sum from the left hand side and maximum sum from the right hand side. Okay, this is some mandatory thing. Even if you get 0, even if you get some negative number, but you need to find it.
So we need an additional element in the node inner class in order to store that max is on the right or left, because we just have right and left object.
Sorry, your question is not clear to me.
Yeah, so I was deep thinking into it that we need in the node inner class another variable to store whether the right is max or the left is max.
No, why so?
How would we store
That we will figure it out, right? Like, don't
okay.
go into the coding process right now.
Yeah, got it.
The question is, if you understood the concept, that's more than enough. The next part, we will proceed, okay? One by, like, one step at a time will be better. Okay, give me a minute. I'll just put on the charger. So similarly, likewise, we consider 12 as our root node. We can consider each and every node in the tree as the root node and find out the maximum sum for that specific node. And at the end, we can just merge like our answers and we will get our maximum sum. Okay. So can you tell me for 12, what will you get from the left subtree? What will be the maximum sum that you will get from the left subtree? $27. Okay. How you are getting 27? $18 minus $39. Okay. You're basically taking 18 minus 4 and 25. 18, 7, 25. Kishan, we need to take a path. We can't split our path, okay? So if you are taking 25, you can't take 7. If you're taking 7, you can't take 25. So basically it will be like 18 minus 4, 14. 14 plus 25, that will be 39. Clear now? Next is what will you get from your right subtree? 16. Yes. So you got from right subtree 39. You got from left, you got from left subtree 39, from right subtree 16, and your root node is 12. So this is going to be your answer. That is 39 plus 12 plus 16. Are you guys clear? So now what we are doing here in this particular approach, we are one by one considering a node. Okay. For that specific node, we are finding out the max sum in the left subtree. We are finding out the max sum in the right subtree. And at the end, we are like just returning our answer. So you can write it here as 1. So overall time complexity here is going to be n squared. Are you guys clear?
Ma'am, 1 second. I'm just counting like the left part is 17, like 10 minus 3 is 7, minus 1 is 6, 6 plus 6 is 12, 12, 5, 17. The left subtree max.
Can you come again? Sorry.
So the max of the left subtree would be starting with 10 minus 3. Yeah.
No, just consider 12 as of now, okay? Not go in the entire tree.
Okay. So yeah, so 39 plus 12, then how did you get 16?
Right subtree, consider 12 and its right subtree. You have minus 2, 18 and 4. So you will go with the part minus 2 and 18, which will give you 16.
Okay, okay, now I'm clear.
Okay, perfect. So this is done. Did you understand the time complexity as well? So we reduce our time complexity of considering pairs to now like traversing the entire tree only once.
Once again, how did you get n plus n plus 1?
N is like 1n is for traversing all the nodes in the tree. Next n is for finding out the max in the left subtree. Another n is for finding out the max in the right subtree. Clear?
Okay. Yeah. And 1 is for the root.
1. Yeah. 1, no, not for the root. It's basically to find the sum.
Okay. Okay. Yeah. Got it. Thank you.
Clear?
Yeah.
Okay, perfect. So the structure somewhere looks like you have the function, you have root node, if if root is equal null, then you can return 0. Otherwise, you can just find out, return max sum from root dot left. Next is you can add root dot data to it. Plus you can find out the max sum from the right subtree. Clear, everyone? Now we are left with implementing the maximum function, how to implement it. But I guess this much is clear to you guys. Okay. Guys, just give me a minute. Okay. Did anyone thought how to write the answer for finding out the max sum?
So we'll go to the, like in recursively, keep adding the value to the left. And if it
Sorry.
is, so keep, I mean, I was thinking in a recursive way, keep going to the left, add the value of the data, and then go to the right, whichever like is greater, we'll assign that as the
See, the thing is, every time you are moving towards the left or right, like obviously you will move towards the left there, but there will be some point at the end where you will be left with leaf nodes. That is the left and the right, correct?
Yes.
And you have to choose one of the path. That means you have to find the max between the left and the right node that time. Are you getting it?
Yes, madam.
Yeah. So that is the case here. Next is, in our previous approach, we discussed that for every node, just give me a minute, I'll show you. What we are trying to do here is, for every node, we are considering it as a root node, and then we are finding out the maximum from the left and we are finding out the maximum from the right. Are you guys getting it? That's what we did. But the thing is, it's getting repetitive, right? Because let's suppose you consider 12 as your root node and you find out the maximum sum from the left subtree, that is 18 minus 4 and 25. Then you found out the maximum from right subtree, that is minus 2 and 18. Okay, that's fine. But when you will be considering minus 3 as your root node, again you will be following the same procedure, finding out the maximum from the left subtree and finding out the maximum from the right subtree. So why not use the maximum sum we have already got at 12 and like not to go again and again inside the nodes? Are you guys able to follow? So using this observation, we are going to modify our course a bit more.
So, ma'am, I have one better suggestion for that. Is that instead of starting from the root, we should start from the leaf and then see that which one is maximum and then keep on going up to the root.
Exactly. So you have got it right. And that particular approach which you are suggesting is known as bottom up approach. And that's what we are going to follow here now. That is, we are like starting from the leaflets and ultimately we are going to accommodate our solution to the root node. Clear? Okay. So we will have our, this is our final answer. You will have your int answer. Let's suppose I'm using a final answer kind of stuff, which is in which I'm going to store my max answer, which I can get out of this tree. And this is stuck. Okay. Here I'll store it as an int min. Then I will write my function int f. Here I'll be having my root node. The condition 1 will be the same. If root is equal null, return 0. Next is, you will find your answer for the left subtree in int L, that is int L equals to f of root dot left. This we are using to reach, like you said now, that we will start from the leaf node. So we will first go to the leaf nodes via this. Next is int r. Again, we will be calling the function, and here you will be having root dot right. Next, what we will get as our current answer. Let's suppose you got in L some of your, like, let's suppose some max sum. You got your answer in the right, in R as your right subtree sum or right subtree maximum. Then you will have your current sum as left plus right plus root dot data. Clear, no? Okay, so you figured out this, then we will be updating our main answer, that is answer equals to max of answer comma common answer, or current answer, not common answer. Clear? Next is what you are going to return from this function. You're going to return, and why I am writing this, I'll tell you. It's because you can have negative data in your tree as well, right? So you will find out
Ma'am, common answer and CSUM are two different things. Like, what's the logic for the
sorry,
common answer?
sorry. CSUM is the same. I have written
Okay,
the
okay, okay.
wrong term.
Okay, yeah.
Okay, so here you will be having, you will take max of L comma R, plus you will be adding your root dot data, and 0. Because what if adding all of these gives you a negative result, and like still it's better, like 0 is better. So we will take that case also. Is it clear to you guys?
No, under what circumstances it will return 0? I understand that if it's a negative int min, then it will return 0.
Kishan, this one is for returning the results to this function f. Okay, answer here we are comparing, and that is our global variable. Okay, so every time we are getting our common sum, we are updating our answer. But what values we will be returning to our L and R will be decided by this particular statement. Are you getting it? Is the flow clear now? And under what circumstances, Vishnu? It's like you have your left subtree, you have your left subtree sum as negative, right subtree sum as negative, and root dot data is also negative. Okay, in that case, are you going to consider any of those?
So, I mean, our answer is a max sum. So even if it is all negative, it's still a correct answer rather than 0. So,
See, this is the condition I'm telling you guys for the scenario where, like, some of the nodes are negative and some of the nodes are positive. Okay, in that case, you have to tackle this via 0, right? Are you getting it?
no, I'm just thinking that since we are adding both negative as well as positive, whatever number comes will be returned regardless of.
No, not whatever number comes will be returned. It should be max, right?
Yeah.
Because whatever number comes and you return it, that it won't be giving you the maximum result. Okay,
So,
let me just show it to you.
So our goal is to get the sum of all.
Max sum.
Yeah, max sum.
Okay. So let's suppose from here minus 19 and minus 4 are there and 18 is there. Okay. So what will you do? You have to choose which part to follow, right?
Yeah.
So that is what I'm doing, max L and max R.
Yeah. So it will
Okay.
return -4.
It will return -4. And then you are going to add 18 to it. That will return you.
16.
4,
No,
right?
no,
14 it
14,
will
14,
return.
14,
Yeah.
14. Yeah, 14, 14.
But what if here it was -18? Then you will get -22.
Yes, -22.
Okay.
Yeah.
Then should 12 take -22 from its left subtree? Should it even consider that particular part?
If right is more,
It should
then
consider
no.
right. Correct. So for that scenario, I am handling it with 0. Are you clear?
Oh, okay. Yeah.
Because when this particular statement will be returning its answer, it should not return -22. It should be returning
0.
0. Clear? There is a scenario where this will fail, which is if all your like roots are negative. If all your nodes are negative, in that case, you have to ultimately see and like decide what should be the answer. Okay, just tell me if all of your nodes are negative in your tree, then what should be your answer? Any ideas?
The least negative number should be
Or
here.
the maximum in the tree?
Yeah. So if left subtree gives me -10, another is giving -2, I should return -2.
Basically, I'll say the maximum in the tree if all the terms are negative, right?
Yeah.
So you can handle that scenario via that case by finding the maximum in a tree. And you know how to find the maximum in a tree, right?
Yeah.
Okay. So now I have explained you the scenarios. Like one is where all the nodes are negative. One is where there is a mixture of both the nodes. So these are the scenarios I am telling you. In this way, the test cases are also defined in all the, you can say, coding platforms. So when you practice over there, you get an exposure. Okay, how should I handle my code? And that is where the real learning comes. That's why I'm telling you guys, please practice over there. Clear? Okay, fine. So if you all guys are available, should I take another question? That is the vertical order of a tree. Okay, one, yes, I have got. Okay. I'll just quickly explain you guys because it's not that a big, because you already know how to write the code for level order. So it's not going to be that big. Okay. So for vertical order traversal, you need to print the data in separate levels. And for that, like any ideas, how can we store that? Can we traverse in the vertical order in a tree? Like the way we were traversing in the level order?
So I was thinking if
It
like
won't be possible, right, Kishan? You can go to the right, you can go to the left, but you can't go straightforwardly in a vertical line in a tree. Yeah. Vishnu, you were saying something?
yeah, so I was thinking that every time we go left, we make it like minus
Hmm.
1, and
Yes.
then every time we move towards right, we make it +1. So at the end, we'll have all zeros in one array, all ones in another array, all twos in another array.
Your thinking
Mm.
is right. Just I will try to frame it a little bit. Basically, what we can do every time you are moving to the left, okay, you just have a value v, which is like at root is 0. If you are moving to the left, make it minus or negative. If you are moving to the right, make it positive. According to those values, make a map. Okay, that is If you have got a value 0, you will have a map where 0 will be the key, and according to that, the values will be pointed in the map. Are you guys getting what I'm saying? What I'm trying to say is, I'll just show you. You have 0 initially. Okay. You move to another level. You make it -1. You moved further down, next level, -2. Now, pointing to the 0 level is 5. Okay. So these will be the value stored. Basically, along with a value v, or you can say integer value, you will be having an array list. 5 will be pointing over here. Then again from here you are going to 12. So if with -1 you will be having value as 12. Next you will be going towards the right of 12. Right means you will add a value. -1 plus 1 will become 0, and you will be having here 3. Next, like already this particular mapping exists, you will just add 3 to it. Next, you will go to -2, -2 pointing to 7. So 7 will come here. When you will go to the right of 7 is 2. So it will come to the level -1, and you will store 2 over here. Are you guys getting it? And this is how you're going to store your map. Okay.
Once again.
It's simple, right? You have a, like whatever function call you have with the root. Okay. With that root, you can pass a value v, which will be initially be 0, as root is at the 0th vertical level. Are you able to follow?
Yeah.
If you move to the left, then always do a -1 from your value, that is v -1. If you move to the right, then always do +1 to your level, that is v +1. Getting it?
Yeah.
Yeah. So when you do this, every time you have a value, based on that, check if that value exists in your map. If it exists, then pointing to that is an array list. Simply add that value to your array list. If there is no mapping over there in your map, add that value to your map and then store that value. Clear? It's basically a map of integer and array list of integer.
Yeah.
Clear?
Yes.
Any questions? Okay, perfect. So if this is done, then I guess we have guys, will you be available for the classes on weekends? Because I am having a target of, let's suppose, 15 days to complete this batch now, because it's getting extended a little bit more. Will you be available on weekends? Like tomorrow, obviously, we are having a doubt session, so no. Day after tomorrow, will you guys be available? Only one yes, others? Okay, for this week, I am getting yes. No, this Sunday not possible. Okay, leave this Sunday. We will discuss it then on the next weekend. Okay. So try to be available on the next weekend. It will be great. Okay, only I can say 2 to 3 questions are left in the trees. I guess you guys have got a lot of questions in the trees to practice. Okay. So I'll just give you a few questions, because since it is our weekend, you can try. I won't be discussing those questions in the class. You can find the content over internet and all, or you can try it on your own, whatever you want to do. Just giving you the question. One is, you have been given a tree for 10, 6, and 3. You need to find the diagonal order traversal of a tree. That is, you need to print this. Then this will come in another diagonal. And then this will come. So this is one question. Diagonal order traversal is very, very easy. You just need to observe it. You'll be able to do it. Next is, you have been given another tree. I'll just write its name. You need to print its left view. Okay, so here it will come 10, 4, 18, 20. Here it will come as -3, 7, 2, 15, and -4. Here it will come as -8, 1, -10, 24, and here it will come as 40. Okay, so if you have to print the left view of this tree, you will have to print 5, 12. Obviously, you know there are no levels here, so you just need to print the numbers 5, 12, 7, 2, 15, and -4. And beyond this, you have 24, so 24 will come. Other numbers are not getting printed because they are getting overshadowed by the left numbers which are getting printed. Clear? Guys, is the question.
Yeah, question is clear, but you know what? Um, where do we use this? Like, why I'm asking is because there we can frame so many questions in like how or where do we use it? What's the point in doing this?
Sorry?
So where do we use this kind of thing in real life?
In real life, I won't say it's used, but these are the questions which are interview based mostly.
Okay.
Okay. So like these are being asked in the interviews mostly, left view, right view. Like you can find the right view of this. You can have the top view of that. So these are few questions which come. Getting it?
Okay.
So if it is a left view, Kishan, I'm not sure of your solution. You can try doing that. Other than that, you guys know how to print the level order. So you just need to print first data of each level, that is the left view. Right view, you can store the entire level order in some kind of map, okay, and then you can print the last data of each level, that. And next is top view, so you know how to print the vertical order. In the vertical order, you need to like see, okay, how to print the top numbers in the top view. So that is something you need to think of. But yeah, these are few questions which are, you can say, easy, tricky, and some things which you need to give a thought about. Clear? Yes.
Unless I
Sorry.
do, it won't be clear.
Exactly. So that's why I'm giving you, because there should be something which you give a thought. If I keep on giving every solution to it, it's like the course will extend a lot. I can't give the solution. I can't discuss the solution in the class all. So you do it. You've asked me the doubt. I'll be available to solve your doubts, but I can't solve every question in the class. Okay. I hope you understand.
Yeah.
Okay, then I'll just stop
Ma'am,
the class here. Yeah.
how's Geek for Geek? Is that a good reference site?
Geek for Geek is good.
Okay.
And there are many, I guess. Tutorials point is there. And yeah, there are so many sites you can refer to. It's just about which site you understand better.
Okay. Okay, thanks.
Okay. Okay, then. Thank you, guys. And happy weekend. Those who are joining tomorrow, we'll see you tomorrow at 9 a.m. Bye bye.